What is up, math magicians? This is section 3.32, analyzing graphs of quadratic functions. This is our second day in this section. And yesterday we actually graphed the functions of the type f of x equals a parentheses x minus h parentheses squared plus k. And now we're just going to graph them of the type here, the general formula for a parabola ax squared plus bx plus c. You'll recognize this from the quadratic formula abc. But the whole strategy is going to be to convert it from this format down to the format that we can graph, the AHK format. In order to do that, we're going to have to isolate x squared plus bx and complete the square. Let me show you what I mean. So here we're given just kind of a standard f of x equals x squared plus 10x plus 23. And now we're going to isolate these first two terms right here. These two terms we're going to get by themselves, and we're going to move everything over here to the other side. So that means subtracting 23, and we get this. Now, once we have this, we have something that we can complete the square with a little easier. Remember, when you complete the square, you take the b value, which is 10, and you divide it by 2. You get 5. Fine. Square it. 5 squared is 25. And these two numbers, the 5 and the 25, are going to show up again here. We want to add this 25 to both sides. Boom, boom. Mostly so that we can get a perfect square trinomial here. X squared plus 10x plus 25. Because we've arranged it in this way, because we've chosen 25, we can actually factor it into x plus 5 squared. Remember, 5 is the yellow number here, boom, and 25 is the green number here. Now, because we've chosen 25, it works as a perfect square. And you can even check it, too, if you wanted to. You could check it by foiling this out. X plus 5 times x plus 5, you get 10x, you get 25. Over here, we can simplify minus 23 and plus 25 down to plus 2. And then bring it over to the other side by subtracting 2 with both sides. Now, because we've done this fancy footwork, and it's a sequence that you're just going to do over and over again tomorrow for the assignment, we can figure out what the a, h, and k values are. A is 1, h is negative 5, because remember, x plus 5, h is going to be defined as x minus h, so it's the opposite of what you see here. H is negative 5, k is negative 2. Done. And from that, we can gather all of the really interesting graphing data that we have. We'll know that it has a vertex of negative 5, negative 2. We'll know that it opens up because the a value is positive. We'll know that the line of symmetry is x equals negative 5. That's where the vertex is. And we'll know that the vertex itself is going to be a minimum at negative 5 comma negative 2. Done. Let's try that again with an a value that is not positive 1. Remember, here we saw that this a value is positive 1, which made things a little easier, but we can handle things that are more complex now, just remembering the strategy of isolating x squared plus bx. So in order to do that, the first thing I'm going to do is I'm going to get rid of this fraction. Nobody likes fractions, dealing with fractions. They always complicate things, so let's get rid of them. So I'm going to multiply all the terms on both sides by positive 2. When I do that, I get x squared right here. X squared over 2 divided by 2. We're going to multiply this term by 2 to get positive x squared. All of a sudden, it's just x squared all by itself, which is great. The other terms times positive 2, minus 4 becomes minus 8x, plus 8 becomes positive 16x, and g of x becomes 2 times g of x. Fine. Remember the strategy, we want to isolate x squared minus or plus bx. So that's what we get here. In order to go from here to here, I'm going to subtract 16 to both sides. It cancels this out, and this becomes 2gx minus 16. Great, now we've got the b value, it's negative 8. I'm going to divide that by 2 to get negative 4. I'm going to square this, negative 4, to get positive 16. Remember, if you're typing this into a calculator for whatever reason, make sure you include the parentheses. And when you write it down, you really should include the parentheses as well to distinguish it from negative 4 squared. Okay, so these yellow and green numbers are really important because we find that we want to add 16 to both sides, and we do right here. So this becomes all of this plus 16, and we have x squared minus 8x plus 16, which happens to be a perfect square trinomial. It doesn't happen to be. We've chosen 16 so that we forced it to be. X minus 4 squared. This minus 4 is the yellow number right here. X minus 4 squared. Now we notice that, lucky us, the 16 and the negative 16 cancel out, so there's nothing down here, and we're just with 2gx. And in order to get g of x all by itself, we're going to divide both terms on both sides by 2. When we do that, these cancel out, but dividing this by 2, you could put it all over 2, and that would be fine. I'm going to write it out front with a 1/2. Equivalently, you could have just multiplied both sides by 1/2. This would cancel out, and this would have a 1/2 right here. In any case, we find out that the a value is 1/2, h value is 4, k value is 0. And that gives us all of the information that we need. You might notice there's a pattern here, and I'll just cut straight to the chase, because the pattern is, if you know what the b value is here, you can calculate the h value with this h is equal to negative b over 2a. The h value shows up in all of this information. It's 4 here, 4, 4. So the h value shows up a lot, and if you know the b value and the a value, then you can calculate h. H is just negative b over 2a. Okay, strategy. Remember to isolate x squared plus bx. And I'm going to start off here. This is going to be about as ugly as it gets. And that's okay. We can handle it. So I'm going to first get rid of the a value. I'm going to move this negative 2 to the other side by dividing all the terms on both sides by negative 2. When I do that, this cancels out and it's just x squared. But the resulting terms are h of x divided by negative 2. Positive 10 divided by negative 2 is negative 5. And minus 23 halves becomes positive 23 over 4. If you had 23 halves, then 23 fourths would be half of that. It's the same thing as multiplying it by negative 1/2. Then I'm going to bring the 23 fourths over to the other side. 23 fourths over the other side, we get this, and now we have x squared and a bx over here. The b value is negative 5. And when we divide it by 2, we get negative 5 over 2. Some people prefer to use decimals at this point, and that's fine. You can use decimals or fractions, whichever is more convenient for you. This is negative 5 halves, and when you square it, negative times a negative is a positive. This is 25 over 4. 25 squared is 25, 2 squared is 4. So here we add the green number 25 over 4 to both sides here and here. The motivation for doing that is that we put this 25 over 4 on here to create a perfect square trinomial. But we can't just do it to one side, we have to do it to both sides. What we do to one side, you do to both sides of the equation. And we see, if you're looking to try and factor this perfect square trinomial, it's really just going to be x minus this yellow number here squared. It's minus because this is negative here. Anyway, 23 over 4, and minus 23 over 4 plus 25 over 4 simplifies down to positive 2 over 4, because 25 minus 23 is 2. then we're going to move this 2/4 over to the other side, and I'm going to simplify it down to 1/2. 2/4 turns into 1/2. And then going to, at this point I'm just getting h of x by itself, so we can graph it. I'm going to move the -2 back over here. That means I'm going to multiply all the terms on both sides by -2. When I multiply both sides by -2, this cancels out, and we're left with h of x, which is what we want. That's the goal, h of x all by itself. This term, this is one gigantic term, and it all gets multiplied by -2 because we've got a -2 out in front. -2 times -1/2, and negative times a negative is a positive, and they're reciprocal, so it just becomes 1. So we've got an a value of -2, an h value of positive 5/2. Remember, because we define this as x minus h. So what x minus what? 5/2. So h is 5/2. K is equal to 1 right there. The vertex is going to be 5/2, 1. It's going to be a downward facing parabola because a is -2. And the line of symmetry is going to be x equals 5/2, and the vertex itself is going to be a maximum. This would be a good time. All right, kiddies, it's play at home time with Desmos. What that means is when I do something on Desmos, you do it too. Make sure you can show me your saved Desmos graphs when you arrive in class tomorrow. This might be a good time to tell you that Juneau is the capital of Alaska. I've never been, but if you've been to Alaska, I'd love to hear about it. So go ahead and write that down as your audio check. Juneau is the capital of Alaska. Okay, so we're using Desmos here to graph f of x equals x squared plus 10x plus 23. And if you, I'm going to do this in projector mode so you can see even better. Here, we can check this out. I'm looking at this vertex down here. It's at -5, -2. It looks like a parabola that opens up, and it has a minimum at -5, -2. Great. The line of symmetry looks like it's at x equals -5. Done. Here, I'm going to take this and divide it by 2 and then -4 to get that, and then +8. So we've got a parabola over here, And I think what I'm going to do actually is I'm going to change this. No, we don't want that. We want A, the general formula, plus B, plus C. And yeah, I do want some sliders. Give me those sliders, because now that we have sliders here, I can say that X, the line of symmetry, is just going to be, no, let's calculate H. H is going to be negative B all over 2A. Great. Negative B over 2A. And then we're even going to plot the vertex. H, comma, f of H. Here. Let's change that to a different color. Blue. Beautiful. And now I'm going to plot the line of symmetry. X equals H. There it is. Okay, so now we can get whatever parabola we want by just changing the A, B, and C value. Here, in this case, for example 2, we want an A value of 1/2. We want a B value of -4. We want a C value of 8. Done. There it is. Vertex is 4, 0. It is an upward-facing parabola. The line of symmetry is x equals 4. As we can see here, x equals 4 right there. And then it is a minimum. The vertex is a minimum because it opens up. And we're done. Okay, so for example 3, we've got -2 as an A value. As a B value, we've got +10. And as a C value, we've got -23 over 2. Look, there it is. The vertex is 5/2. That's 5 divided by 2, which is 2.5. It is a downward-facing parabola because A is negative. And then the line of symmetry is x equals 5/2, or 2.5. And this vertex is a maximum. A, B, and C sliders make life a lot easier once you type them in. I'm going to save this as 3.32, analyzing graphs of quadratic functions, day 2. Save. And we're done. Okay, so in general, we're arriving at a formula for the vertex. And so you can see that a standard parabola starts out as ax squared plus bx plus c. In fact, any parabola can be defined in terms of a, b, and c values. So you're given this general standard formula, and then it'll look like this, or maybe it'll be upside down. But in general, you'll have 2 intersection points, and you can calculate them using the quadratic formula. You know, this is a solution. If f of x equal to 0, then this will be a solution here, and this will be a solution here. And realizing that parabolas are symmetric, then halfway in between these two should be the line of symmetry and the vertex. So if you average these x values, like if you add them up and divide by 2, what you get is you get negative b over 2a. This minus square root and this plus square root cancel out, and you add the 2 together and divide by 2, then you get negative b over 2a. If you want to find out where this vertex is, you'll take the value of negative b over 2a and put it into the function. So this works for all parabolas, even if it doesn't intersect the x-axis and you have imaginary solutions. Still, you can find the vertex of the graph by calculating negative b over 2a, and then put it into the function to find the y value. X-coordinate, y-coordinate. Let me show you where that shows up. Here, in this function, you find the a, b, and c values, and then this green number here is the same as the green above, negative b over 2a, negative b over 2a. When you simplify that, you get 7, so that's the x coordinate of the vertex. And then when you plug 7 into the function, you get all of this, which simplifies down to 2, which is the y-coordinate of the function, 7, 2. It's a maximum. New question, what's the range? Ooh, it's kind of hard to visualize. It's hard to answer the question, what's the range, if you don't have a visual. And so what I just did was I drew a quick sketch. This vertex is at 7, 2 right here, 7, 2, and then I know it's going downward because there's a negative a value. That's really key for the range. Because you can see that the range, all the y values that we're involving here on this parabola they go from negative infinity all the way up to this y value here, the y value of the vertex. So they go from negative infinity up to positive 2, including infinity, so brackets on a 2. When is it increasing or decreasing? Well, looking at the quick sketch that I made, maybe it's even worthwhile to label that sketch. The vertex is 7, 2, so therefore it's increasing from negative infinity, these are x values, mind you, negative infinity all the way up to positive 7. Then it's decreasing from 7 all the way up to positive infinity here. Let's try another one. Here, x squared plus 10x minus 20, we get the a, b, and c values. A is equal to 1, b is equal to 10, c is equal to negative 20. We plug them into our new formula, negative b over 2a, all over 2a. Same idea. X equals negative b, blah, 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 all over 2a. It's from the quadratic formula. Negative 10 over 2 times 1 gives you negative 5. So negative 5 is going to be the x value of the coordinate. And you get the y value by plugging negative 5 into the function. When g is negative 5, then it all simplifies down to negative 45. That's where the vertex is. And I even draw a quick sketch of the graph just to keep myself organized, to give myself a visual. It is opening upward because the a value is positive 1. And the vertex itself is a minimum. I want you to find the range. What y values do we encounter when we draw this parabola? If you want, you take a hint from this. It'll be some sort of interval of y values. But be careful because it does open upward, and this example opens downward. Although we can see that it's decreasing from negative infinity all the way up to negative 5, that's the x value. And then the x value of negative 5 up to positive infinity is where it's increasing.